So you have a whole piece of paper and 2 quarters, yes? I want you to put the quarters aside for just a second and take your whole piece of paper. See how I have it landscape? I'm going to fold it in half.
Is that hot dog or hamburger?
Rude.
We can't talk about that. Is that booger?
I'm going to hold it up so you can see it. Okay, so I fold it in half. Or we can say books. That's fine because I have books.
We have no books to share.
Since my husband got me Kindle Unlimited in January, from January till now, I've read 460 books.
How do your eyeballs not hurt?
Well, I work them out. I work my eyes out. I just read a lot, so they're buff. My eyeballs.
Like you do with the...
Now, see what I'm doing? I'm taking one and I'm folding it back. And try to get these as exact as you can because that'll make this easier. Okay? So now I have this. Right? Now I have this. Now I'm going to take this side over here and I'm going to fold it this way.
Wait.
So when I stand it up on the end,
Wait, so when I'm here, do I fold back this way?
yes sir, that's perfect. Yep.
Move off.
So whenever you stand it up, no cord does it.
Now here's where I don't want you to get confused, okay? If yours is accidentally a W, that's still okay. Okay? That's allowed.
Like to be a W and an N.
Okay, so are we okay so far? Yes or no? Yes. Okay. So what I want you to do is I want you to lay it down so that you can open it like a book. Like this. Does that make sense?
I like so.
Okay. Take your scissors. Now, see how I'm grabbing the middle? See how I'm grabbing the middle right here? Now it's a bird. Good. Okay. Now I'm going to cut the bird. I guess. If you're giving me those examples. Okay, watch me. I'm cutting the middle.
All the way up.
And I'm cutting the middle all the way to the fold. I didn't go past the fold, but I went right up to the fold.
And we're cutting straight in the middle.
Cutting it straight as close as you can to the middle. We're not going to measure it. We're not going to freak out if it's not exactly in the middle, but get it as close as you can to the middle. Everybody okay? Look at your table groups. Make sure you're all doing the same thing. And if you're not, ask. Okay? Now, do you see now I have 2 halves right here? Now I need to cut this one in half all the way up to the fold. And I need to cut this one in half all the way up to the fold. So that this is what I have.
That's not perfectly hard.
Why is yours perfect? I guess you're just amazing. You're okay.
Mine's not perfect.
Oh, that's okay too. Is everybody here? Some of you are here, some of you are getting here. Those of you who are here, what I want you to do is fold the folds like backwards and forwards so they're flexible. Backwards and forwards so that they're flexible. See what I'm saying? Yes or no? I'm taking this one and I'm folding it backwards and forwards so that it's flexible. And then I'm going to take this middle one, all these 4 parts, and I'm going to fold them backwards and forwards so that they're flexible.
I can do that one. But this, do it again.
It's okay. I'm just showing you. Yeah, I'm showing you again. That's fine. I'm just doing all the folds backwards and forwards so that all the folds are flexible. Because I want to be able to fold them both ways and not have any trouble. Okay, did everybody see what I did? Now when you're done, I just want you to lay it flat. So you can see I've got the folds in the middle, or the cuts in the middle, and I'm just laying it flat. No. Now I'm going to take this.
Wait, pause.
I'm pausing.
No, pause.
Now unpause.
Unpause.
Okay, unpause. Now weave it through like that.
Do we do the other one opposite?
Yep. So that one's there,
This is cute.
and then I do the other one opposite. Now, guys, I know some of you are having trouble with seeing the yellow because that's kind of bright up on the screen, but I tried last period with two other colors, and it was too hard to differentiate between the squares. So these are the two colors that I found that work the best. So sorry about that. Okay?
Okay, time out. Oh,
Yeah, go from the back. Just like that.
My paper too big.
So this is where I need us.
this looks pretty cute.
Perfect.
I did it.
Okay, now you need to close it. Fold these in. So I just folded the outside in, and then I'm going to fold it this way. Why are you woeing me as if I was a horse? This is where I started. I folded the outside two over, like in, and then I picked it up and closed it like that. So that when I lay it flat on the desk and I open this first fold, that's what I can see. And then that middle goes next, and then the last. So it's like a book. All right, I'm opening it like a book. Anybody have any questions about this?
Wait.
Perfect. Anybody else have any questions? Can I help with anybody?
Give me my sister.
Okay, you ready? All right, first things first. What is this foldable called? What's it called? Transformations. This is called transformations. Okay, remember this is where I'm opening it like a book, so that's the front, is transformations. Okay? Now I'm going to take the whole thing and turn it all over so that this is the back. Guys, please don't write my name. Please write your name. Write your name on the back. So on the front, we have transformations. And on the back, you have your name. Flip it over. Flip it over. Turn it this way. Like, spin it. Perfect, just like that. So the front says transformations, and the back says your name. Yes? Everybody okay? Okay. So the first thing I want you to do is open it. You can't see transformations and you can't see your name. We good? All right, I'm going to zoom in so that you can see the top two squares. Okay? first one we're going to talk about was y equals f of x plus k. Y equals f of x plus k. And this column is going to be y equals f of x minus h. Everybody okay so far? Okay. Now, we're talking about our parent functions, right? Our parent functions that we started with, plus we're adding something or subtracting something. Same thing here, the parent function, but I'm adding something or subtracting something. Does everybody understand that? Okay. Do you recognize that this k is outside of the function? Here's the function. You see that k is outside of the function. Do you see that h is inside of the function? See how it's inside of the parentheses there? Do you see that h is inside of the function? Yes? Okay, so here's what I want you to know. This is going to be true for every one of these that we make today. If it's outside of the function, it causes a vertical change. It's vertical. Well, if outside of the function causes a vertical change, what do you think inside? Perfect. Now, there's a specific reason why we use h. Yeah, it's horizontal. It helps you remember. Now, we couldn't use a v right here. That would be weird. So vertical. Yes? Okay. Now, what are h and k doing to the functions? What kind of mathematical operations are they doing to the functions? Adding and subtracting, right? So if they are adding and subtracting, that is going to cause a vertical shift. If it's adding or subtracting, that's causing a shift. Now, sometimes this year I'm going to tell you silly stuff so you remember it. Silly, so you remember it. But if I'm wanting you to remember it, it means it's important. I'm about to tell you something here. Everybody ready? Okay. In this word, the most important letter is the F, because if you leave it out, it's a whole different word.
Oh my God.
Mm-hmm. And why do you think I have to have that rule?
Because it's a bad word.
Because you can't say that word.
Because somebody has done it.
Mosquito.
Right? Somebody's done it. Somebody accidentally wrote vertical shift, but without the F. Yeah. So let's try to remember our F's. Is that all right? Yeah? Okay, now let's talk about specifically about vertical shifts. We could be adding the K or we could be subtracting the K. Right? We could be adding the K or we could be subtracting the K. Does that make sense to you?
Yes, ma'am.
Now, vertical changes are very logical. Vertical changes are exactly what you think should happen. Well, what direction is vertical?
Up, down.
Up and down, right? So if it's plus K, which direction do you think it would move? Up. And if it's minus K, which direction do you think it would move? Because like I said, it's very logical. Okay? Horizontal, on the other hand, is backwards. It's totally backwards of what you think it should be. So which direction, first of all, is horizontal?
Side, what's right?
So left and right. So if it says x minus h, which direction do you think it should go?
Left.
You think it should go left because
But
it
it
says
can go
minus,
right.
but it's backwards, so it is moving right. If it says x plus h, which direction do you think it should be moving? You think it should be moving right because it's plus k, right?
But it just.
But it goes back. It's backwards of that, so it is
Left.
left. Now, can I give you some examples of what I'm talking about this whole time? So in this bottom section right here, I'm going to have two graphs. And the first one is just going to be an absolute value parent function. And we know that the absolute value parent function looks like what? Doesn't it look like a V? Absolute value. Remember that? Well, what if it says actually y equals the absolute value of x plus 2? I know that the 2 is outside of the parent, so I know it's a vertical shift. Because it's plus 2, I know it's moving up. So that means I take the whole entire graph. It doesn't change the shape, but I just move it up 2. Does that make sense? Two graphs in this one. Let's make this one be y equals x squared. That's our parent function for a quadratic. And we know that looks like a parabola, right? But this time, what if I say y equals x plus 1 in parentheses squared? Well, that's inside, so I know it's a horizontal shift. I know it's a shift because it's being added or subtracted. I know inside means it's going to go backwards of what I think, so it says plus 1. So instead of going right, it's going to go left. So that means I take my original shape, my original parabola, and I just move it 1 to the left. Any questions so far? Okay. Take this whole thing. Let me zoom back out. I want you to take this whole thing, and I want you to flip it. Oh, sorry. You got it? Okay. Take the whole thing and flip it over. So now you can see your name and the word transformations, right?
Right.
So now I'm going to zoom back in so you can see the top squares. And we're going to start with y equals a f of x and y equals f of b x. Now, first of all, remember how we talked in the first example about inside and outside? Can you tell me which one of these, either A or B, is inside? B, and which one's outside? A. So you see how B is inside the function and A is outside of the function? Yes? Remember what I said about outside of the function? Outside of the function causes what kind of change? Vertical. But this time, A is not being added or subtracted, is it? This time, what is A doing to the function? It is multiplying. Okay? When A is a multiplier, it does cause a vertical change, but this time, it's a stretch or a shrink. A stretch or a shrink. Shrink. Yeah, getting smaller. Sometimes the curriculum we use, or some worksheets, it might say stretch or compression. But do you understand those two words mean the same thing? Okay. And I write shrink because it has less letters. Okay. All right. Where is this multiplier? Inside. So what kind of change does it cause? Very good. And because B is a multiplier, what kind of change does it cause? Good. Any questions? So we have to know how to tell the difference whether it is a stretch or a shrink, don't we? So for vertical stretch or a shrink, oops, that's supposed to say stretch. It's going to be a stretch if A is greater than 1. Well, that seems logical, right? That it would get bigger if A is bigger than 1, right? But what about a shrink? Less than 1, right? That's a good start. But because of something that's coming up that we haven't gone to yet, here's what I need you to write instead. That's part of what you said, right? A is less than 1, but it also has to be greater than 0. So what I'm saying is that it can't be...
It has to be in between 0 and 1.
It can't be negative, right? Okay? Because negative is something else, and we'll get to a negative in a second. But to be a stretch, A has to be greater than 1. to be a shrink, A has to be between 0 and 1.
That has to be 0.
Oh, it can't be 0. If it's 0, that changes the whole, it's not this thing anymore, right? So that's why I didn't put greater than or equal or less than or equal. See what I'm saying? Good question though. Okay? Now think about what I said between vertical and horizontal. Vertical is very logical, right? And horizontal is backwards, right? So what makes a stretch? If B is what? Less than 1 and greater than 0, right? It's backwards. It's backwards of what we think. A stretch seems like it would have to be bigger than 1, but it's not. It's backwards of that. And a shrink?
It would be backwards.
So B would have to be greater than 1. See how these two are just flipped over? Yes? Okay. Now, in the bottom ones, can I give you some examples? So 2 graphs, the parent and then the example. The parent and then the example. Okay? So on this one, we're going to choose y equals x to the 3rd. Now we know it looks like this, right? We know that's what the parent looks like. I know you remember that, even if you are pretending that you don't. You could at least look at your notes and tell, right? Okay, good. But what if it said y equals 4x to the 3rd? Is 4 greater than 1 or is 4 between 0 and 1? It's greater than 1, so it's a stretch. It is a vertical stretch, so I'm taking top and bottom and I'm pulling them. I'm stretching them upwards. So what it actually ends up looking like is this. There's still a turn there in the middle, right? But I took the ends and I stretched them out. So does it make sense that it would get closer to the x-axis? Does it make sense that it would get further away from the y-axis? Yes? Okay. For a horizontal stretch or shrink, let's use y equals the cube root of x. So I know it looks like this. But for our example, let's say y equals the cube root of 4x. So if it's is this a vertical stretch or a vertical shrink? Because b is 4, so it's a shrink. It is a horizontal shrink, so horizontally, I'm just going to squash it. So does it make sense that it would look like this now? Because I took this and I just squashed it. Now here's something interesting. If I just gave you 2 graphs, a parent and a transformed graph, could you tell by looking whether it was a vertical stretch or a horizontal shrink?
Yes.
You can't. Vertical stretch pulls this way, horizontal shrink squashes this way. Wouldn't they look exactly the same? They do, right? In fact, the only way you can tell for sure is if you can see the equation. Okay? Any questions so far? Okay, now, if you haven't seen the surprise yet, you're about to see the surprise. I want you to flip it back over so that you can't see transformations in your name. So we're in the front. And I want you to start to fold it back up. But watch. Just watch for a second.
What?
Oh my goodness, it's blank.
It is.
Oh, we got more than this.
Yeah, we have a couple more notes we have to take, but now we have a space for them. Right? I think that's kind of cool. Do you think it's kind of cool? You're impressed? Okay, awesome. That's what I live for. Okay, ready? I'm going to zoom back in so you can just see the top 2. We're going to start with y equals negative f of x. Remember I told you we would get to the negatives in a minute? We're here now. Y equals f of negative x. So we have y equals negative f of x, and we have y equals f of negative x. Okay? Now, if it's outside, can you tell this negative is outside? Can you tell this negative is inside? If it's outside, what kind of change does it cause? A vertical change, right? Well, I'll tell you right now, a negative is going to cause a reflection. Well, a vertical reflection would look like this, right? Well, what is that reflecting over? The x-axis. So this is a reflection over the x-axis. Okay? What about this one then? You know it's a reflection because it is a horizontal change. So does it make sense that it would be the y-axis? Good. This time we don't have anything for these two boxes. There's not anything we need to be more specific about, and I can go straight down here to give you examples. Okay? So 2 examples, 2 graphs for each one. So for this one, we're going to say y equals 2 to the x. That's going to be our parent function. We know that is an exponential parent function that looks something like that, right? So it would look like negative 2 to the x power if we're talking about a negative on the outside, right? So if it reflects over the x-axis, it's going to look like that. See, if I folded it on the x-axis, it would be down here instead. Over here, let's do y equals the square root of x, which we can remember or look up to know that it looks like that. So this time, if our negative is inside the function, so it would be the square root of negative x, which axis there is it reflecting over? So it's going from here to here. So instead of here, it's going to go here. Does that make sense? Any questions?